All right, so today we're going to start our unit on trigonometry. All right, so trigonometry is looking at triangles, right triangles, a little bit differently than we have been looking at them. So far, we've been just concerning ourselves with where's the hypotenuse and then where are the legs. Okay, so in this picture, if I asked you to identify the hypotenuse of this right triangle, what would we call it? C, the little c, right? So you could either call it segment AB, or you could call it has a length of c units. Okay, and then so this is the hypotenuse, we can label it. HYP for hypotenuse. Okay, and then the legs, what's one of my legs?
A and B. AC.
AC is the name of the side, segment AC, which has a length of what?
I don't know.
B.
Oh.
That's a leg.
And also CB.
And also CB, which has a length of little a. That's also a leg. Now, when I look at this picture, am I going to be able to use special right triangles like A and B equal each other and then C is the leg square root of 2? Why not? Why can't I use special right triangles? Because why? It doesn't have the angles. I don't know that this is 45, 45, 90. I don't know that this is 30, 60, 90. So because I don't know the angles, I can't use special right triangles. So we're going to look at our triangle a little bit differently. Okay? We're going to look at them with respect to the acute angles. All right? So for example, we could be standing at angle A. So you can draw yourself there. My eyes are really close together.
Why is his eye not going?
That's me with really close together eyeballs. All right, so if I'm looking at that, then we still refer to the hypotenuse as the hypotenuse. That doesn't change. So my side that's labeled with a little c is still my hypotenuse. But the other two sides, we identify them differently, okay? So if you're standing at angle A, if this is the angle I'm working with, if I look across the triangle, we call this leg the opposite side. We call that leg the opposite side. So A, and we just abbreviate it with OPP, opposite. Okay? Now, the other side is right next to where I'm standing. So if I'm actually standing there, if I had drawn my body there, this side is one I could just reach over and touch. It's right next to where I'm standing. What is the geometric word we use for something being next to? Adjacent. Very good. So we call this one the adjacent side, which we abbreviate it with ADJ. ADJ, adjacent. Okay? That's if I'm standing at angle A. All of this changes if I move and I'm no longer standing at angle A. If I say, no, I'm not standing here, now I'm standing over here at angle B, then my hypotenuse is still in the same place. That never moves. Your hypotenuse is your hypotenuse is your hypotenuse. So C is still my hypotenuse. But the side that's opposite has now moved. If I'm at this angle and I go across the triangle, what's my opposite now? B. So now this is opposite. And so my adjacent side, the one that I'm touching when I'm standing at angle B, is now A. When we're doing trig, the first thing you're going to want to do every single time is you're going to want to label your hypotenuse, your opposite, and your adjacent. If you come ask me for help and you haven't labeled your triangle yet, I'm going to ask you to do that before I can help you. Okay? All right, so let's practice labeling. We're going to label the sides as opposite, adjacent, and hypotenuse with respect to angle X. Yes, when we say with respect, it means that's where you're standing. It tells you where you're standing at. Okay? So I'm going to be standing here at angle X. So if you want, you could even draw yourself there. Which side is my hypotenuse? I always label that one first.
Oh, AB.
AB. Which side is the opposite? AC. And if you have a hard time finding it, think of this as like a little bow and arrow and you're shooting out of it. What you hit is always going to be the opposite side.
Miss, I have
Yes.
a question.
Yes.
That little box, that's supposed to be 9 degrees.
Yes. It's just a little askew. Okay? All right, and then so that leaves which one to be adjacent? CB. Okay? All right, when I look at the next one, it looks like the same triangle, but this time my X is at angle A, so I'm standing over here. Which one's my hypotenuse? It's still AB, it hasn't moved. Which one's opposite? And if you have, again, you have a hard time doing that, think of it like a little bow and arrow. It's shooting to the opposite side. Leaving which one to be adjacent? AC. Okay? If you can do this, then trig is going to be simple for you. If you can label your triangle, trig should be simple for you. So let's practice this a few more times. So my next triangle, I'm standing at angle X. Which one's my hypotenuse? The left, the right, or the bottom? The bottom. Which one's opposite? The left or the right? The right. Leaving this one to be adjacent. Okay? The next one, I'm standing here at angle X. Which one's my hypotenuse? The left, the top, or the right? The left.
Oh, wrong triangle. Okay.
Which one's opposite? The top or the right?
The right.
The right. And again, if you need to draw your arrow, you can. Leaving the top to be adjacent. Okay? 2 more labeling problems. All right, the first one, here's my angle, so here's me. Which one's my hypotenuse? The left, the top, or the right?
Right.
The top.
Oh, yeah, the top.
My hypotenuse. Which one's opposite? The right. Leaving the left to be
Adjacent.
adjacent. All right, one more. I'm standing here in the lower left. Which one's my hypotenuse? The right, kind of bottom right, right? Which one's opposite? The top. Leaving the left to be adjacent. Okay? So notice we're talking every time about hypotenuse, opposite, and adjacent. Hypotenuse, opposite, and adjacent. So now it says trig ratios. That means trigonometric ratios. What is ratio a fancy word for? Fraction. So that means trigonometry is just dealing with fractions, but that's okay. They're easy, I promise. Okay? Do you see this funny looking word? SOHCAHTOA. There's an A on the end, right? So we say SOHCAHTOA, and that's how we remember our trig ratios. Okay? Our trig ratios are sine, cosine, and tangent. And then after each one, you have either an O, an H, or an A, a pair of those. Think about what we were just labeling. What do you think the O stands for? Opposite.
Miss, did you spell sign wrong? Is that supposed to?
That's how you spell it. I didn't spell it wrong.
Wait, what sign? Stop sign?
No. Sine, the trigonometric ratio. A stop sign is spelled S-I-G-N. This is S-I-N-E. It's different. Okay? What do you think the H stands for?
Height.
Hypotenuse.
All height.
What do you think the A stands for?
Adjacent.
Adjacent. What does the H stand for? Hypotenuse. The O?
The
Opposite. And the A? Adjacent. Okay? And notice there's different ways it's written SOHCAHTOA, and then it's also written S, and then O over H, C, A over H, T, O over A. That shows you your ratios. So the sine is the ratio of what over what?
The opposite of
The opposite over the hypotenuse. The cosine is the adjacent of the adjacent over hypotenuse. And the tangent is the ratio of the opposite over the adjacent. I put an extra A there. That's okay. Okay? So when I look at this table here and it says I want to find the sine, the cosine, and the tangent if I'm right here at angle A. So with respect to angle A, so if I'm standing over here at angle A, first thing I need to do is I have to label hypotenuse, opposite, and adjacent, what we've just been practicing. Which one's my hypotenuse? C. If I'm here at angle A, which one's opposite? The little a. And then adjacent is B. Sine, remember, so opposite over hypotenuse. What'd you say opposite was? A, and the hypotenuse is C, so the ratio is A over C. Cosine, adjacent over hypotenuse. What's adjacent? B over my hypotenuse, C. And then tangent is TOA, opposite over adjacent. What's opposite? A over B. And then we can do those same things, but this time instead of being at angle A, we're going to be at angle B. So that means my hypotenuse doesn't move, it always stays the same. But my opposite's going to change. Now my opposite's going to be B, and A will be, very good, adjacent. So now if I want to find the sine of angle B, sine is still opposite over hypotenuse, but it's a new opposite. What's my new opposite? B, it's the same hypotenuse, so it's still B over C. My cosine, ca, A over H, which is going to be A over C. And my tangent, B over A. Do you notice anything interesting about my fractions? The sine and the cosine ones switch places, right? And then the tangent ones do what? They flip over. What's the math word for flip over a fraction? Reciprocal. Very good. So my tangent ones are reciprocals of each other, and my sine and cosine completely switch places. Okay? So let's practice this with actual numbers. It's okay. You're okay. I promise. Okay? We want to find the sine, cosine, and tangent of angle A and angle B. So we're going to do it twice, just like we did with our table. Okay? Now, in math, we like to abbreviate when we can, and when we abbreviate, sometimes that makes y'all say the wrong thing. So I'm going to remind you, every time you see sine, you still say sine, even though we're just going to abbreviate it with S-I-N. It's not sin. We're in geometry. We call it sine. And you have to tell it what angle you're standing at. Do you want to start with A or B? A. Sorry. We'll start with A. All right. So we're going to start at angle A, which means we have to say we're taking the sine of angle A, and then we say it equals. Okay? I need to label my triangle. Which one's my hypotenuse? 13. If I'm at angle A, Which one's opposite?
5.
5.
And then 12 is adjacent.
So that makes this one adjacent. Sine of A. Sine, opposite over hypotenuse. What's my opposite? 5. What's my hypotenuse?
13.
Then all you have to do is say, does that reduce?
Yeah.
No.
Then I'm done. I told you it was easy. Cosine
Ceasing?
of A. That's how we abbreviate that. Cosine of A, but we don't say cos A. We still say cosine of A. Cosine of A, if I look up here, cosine, ca, is adjacent over hypotenuse. What's my adjacent?
12.
12. What's my hypotenuse? And then I look at it and I say, can that reduce? Then I'm done. All right, and then the last one, tangent, TOA. So I'm going to abbreviate this, TAN, of angle A. TOA, TOA, opposite over adjacent. What's my
5
opposite?
over 12.
5, and then my adjacent is 12, so 5 over 12. And then ask yourself, can that reduce? Nope, I'm done.
That was easy.
So that's angle A. We still need to do angle
B.
B. So now I'm standing here at angle B. Does my hypotenuse move? Nope, it's still 13. But my opposite is now
12.
Adjacent.
12, the old adjacent. Which means my old opposite is now
B adjacent.
the adjacent. I'm going to do the same thing I did before. The sign of, instead of A, I'm going to put
B.
B. Sine is O over H.
Opposite over.
Opposite over hypotenuse, O over H. So what's my sign?
12 over 13.
12 over 13.
Oh, yeah.
Does that reduce?
No.
Nope. Cosine.
5 over 13.
Good, 5 over 13. And then tangent,
12 over 5.
12 over 5. And you can look and check it and say, did my sines and cosines switch? Yes. Did my tangents become reciprocals? Yes. Okay. All right, on this last section, we're going to find the sine, cosine, tangent of the indicated angle as a reduced ratio. So the first thing I need to do is figure out what angle is the indicated angle. If you look at this triangle, which one do you think they're talking about as being indicated?
52.13.
The 53.13, angle L. Okay, so this angle here is my indicated angle. This is where I'm standing. Okay, so I want to find the sine, the cosine, and the tangent of the 53.13 degree angle. Okay. Sine, opposite over hypotenuse. I haven't done what yet? I haven't labeled. Which one's my hypotenuse? 20. Opposite is 16. Leaving the 12 to be adjacent. What's the sine of 53.13? 16 over 20.
It reduces.
It does. What does it reduce to?
4 over 5.
4 over 5. Okay. The cosine of 53.13. Cosine
12 over 20.
is what? 12 over 20.
That also reduces.
It also reduces. What does that reduce to? 3 over 5. And then tangent, TOA, 16 over 12. And that reduces to 4 over 3.
Oh, yes.
And that's all you have to do. Just make your ratios and reduce them. That's it. You're done. Look at the next one. Which one's my indicated angle? 36.87. So I want to find the sine, the cosine, and the tangent of 36.87 degrees. What's the first thing I need to do? Label. Which one's my hypotenuse? 40. I'm standing at angle J, so that's where I'm at. Which one's opposite? 24. Leaving the 32 to be
Adjacent.
adjacent. Sine. What's my sine?
24 over 40.
24 over 40. Does that reduce?
Yes.
To what? 6 over what?
3 over 5.
3 over 5. All right, and then my cosine, ka, is going to be what?
32 over 40.
Adjacent over
Adjacent hypotenuse, 32 over 40,
Which is 4 over 5.
which is 4 over 5. Very good. And then the last one, tangent of 36.87, TOA. TOA, O over A,
24 over 32.
24 over 32,
3 over 4.
3 over 4.
So we only have to do one of these, like one angle.
Right, yes, just one angle. Just the angle it's asking you for. Now, if you look at this angle, triangle, and you look at the other triangle, they have kind of matching angles. And if you notice, the sine and cosines are switched, and the tangents are
Flip.
flipped, because if you take this angle, my 36.87, bless you, and the other angle, the 53.13, together with the 90-degree angle, you get all the degrees in your triangle. So my two triangles are similar. They have all the same angles. So they're going to have the same trigonometric ratios, even though they have different side lengths, because they're similar triangles. All right, number 3. Yay, square roots. We want to find the sine, cosine, and tangent of which angle? X. I want to find the sine of x degrees, the cosine of x degrees, and the tangent of x degrees. What's the first thing I need to do? Label. Which one, if I'm standing here at x, which one's my hypotenuse? 24 square root of 3. Which one's my opposite?
12 square roots of 3.
And my adjacent?
36.
Sine. What's my sine?
Opposite over
Opposite over
hypotenuse.
hypotenuse, so that's going to be 12 square roots of 3 over hypotenuse 24 square roots of 3. What happens when you divide something by itself?
It cancels out.
It cancels out, so that means
12 over 24.
it's just 12 over 24, which is 1/2.
Yeah.
I did it myself.
All right. The next one, cosine, ka. Adjacent over hypotenuse. What's my adjacent?
36.
36. What's my hypotenuse?
24 square roots of 3.
Am I allowed to leave a square root of 3 in the denominator? No. So what do I have to do?
Add one on top.
Yeah. I can't just put it on the top. I also have to put it on the bottom. We call that rationalizing. Remember, we talked about that. So on the top, I have 36 square roots of 3. On the bottom, I really have 24 times what?
3.
3. What's 24 times 3?
72.
72. So then all I have to do is look and see, does this fraction reduce?
Yes.
To what? 1
Square roots of 3 over 2.
Half.
1/2. So it's 1 square roots of 3 over 2. Or you could say 0.5 square roots of 3, since 1/2 makes a nice pretty fraction. You could also just do you have to put the 1 in front?
No.
No, you could just do square root of 3 over 2. And that would be all right also.
So you can't have a square root on the top, but you can have it on the bottom.
Right, you can't have a square root on the bottom, but you can have a square root on the top. All right, tangent of x, TOA, opposite over adjacent. What's my opposite? 12 square roots of 3 over 36. Do I have to rationalize this one? No, because my square root is okay to be on the top. But when I look at my fraction, does that reduce?
Yes.
Yes, to what?
1/3.
1/3. Can I make that one a decimal?
No.
No, because it's a repeating decimal since it never stops. Like 1/2 becomes just 0.5 and you're done. It doesn't keep going. But 1/3 is 0.3333333 and I'd eventually have to stop, right? So I have to leave this one as 1/3 or 1 square roots of 3 over 3. Do I have to write the 1? No, I don't have to write the 1. It's not wrong if you do, but I don't have to write the 1 right there. Okay, so I can leave my answers here as square root of 3 over 2 and square root of 3 over 3 for my cosine and my tangent. Do I know how big angle x is?
No.
What's the relationship between the opposite and the hypotenuse? 12 square roots of 3 and 24 square roots of 3. Oh, to get from the leg to the hypotenuse, I multiply by 2. And then look at from my leg JK to the 36. Am I multiplying by a square root of 3?
Yes.
So could you say that matches the pattern from a 30, 60, 90 triangle?
Yes.
Yes.
Yes. Which one's my short leg? J to K.
JK.
This is my long leg.
Yeah.
So that means X is either 30 or 60. Which one is it?
30.
30, because it's across the shorter leg. The smaller angle's across from the shorter leg. So I do know that this is a 30, 60, 90 triangle. Okay? All right. So now you'll have an exit ticket that you should be able to complete before class is over.
Yeah.
Yeah?
Yes, sir.